Welcome to a lesson with Dr. Powell. Let's talk about how we can find a power series representation for a function if we know its derivatives. Let's first think for a minute. E to the x, and let's suppose that it's equal to some power series or some kind of infinite polynomial, if you will. It's going to be equal to something like this, where these are coefficients. The coefficients are going to be like a sequence, and we'll put the power of x associated with that coefficient as a subscript. Okay, so, and it keeps on going. Let's see what we can do. Well, let's figure out what this coefficient is. To figure out this coefficient, all we have to do is plug in a 0 to both sides, because plugging in 0 will make all of this go away over here, and this will be 1. So we can say at x equals 0, this becomes 1 is equal to a0. That's nice. Now, let's figure out how we can find a1. To find a1, let's take a derivative of both sides. What good would that do? Well, derivative of this side is e to the x, right? Derivative, and over here, this constant goes away. Boom. So then the lowest thing is this one, and notice that it's a constant term now because we take the derivative of a1x, we just get a1. Here we get plus 2a2x, and here we have plus 3a3x squared. So how do we find a1? Well, let's plug in x equals 0 now into the derivative of this. So this is the first derivative, and we're going to plug in. This is the first derivative, and what we're going to do is we're going to plug in 0. So we plug in 0, and we see it's 1 equals a1, and all the rest is 0. Okay, now let's figure out how we're going to find a2. Let's take another derivative. So this side is still e to the x. Over here we have 2a2, and then here, let's see, we have plus 6a3x. And of course, there's more things here that we haven't really had yet. Okay, so to find a2, notice it's the constant term. So let's plug in 0 everywhere. Realize this is the second derivative. We're plugging in 0 to it. And we're going to end up getting on this side 1 is equal to, and over here we have 2a2. So to find a2 now, we divide by 2. So we divide the second derivative plus 0 plugged in, which is 1. We divide that by 2, and that gives us a2. Now notice, see, when we took a derivative, that 1 came down, so we have a 1. So this is like divided by 1. This is like divided by 2 times 1. We'll keep that in mind. And then the first guy right here that we found a0 was simply just f of 0 itself. Okay, and we could say divided by 0 factorial, if you will, which is like the empty product or just 1. We could just throw that in there. Now, how do we find a3? We take a derivative of this equation. We have e to the x is equal to 6a3 plus a lot of things with x's in them. When we plug in 0 into this, all this will go away, and we'll be left with 6a3 is equal to 1 when we plug in 0. This is the third derivative with 0 plugged in, would yield 1 is equal to 6a3. And then we divide. Remember what 6 is here. 6 is 3 times 2 times 1, which represents what we've been doing with derivatives as we've been going along. The first derivative that we took, we brought down a 3. This next one we brought down a 2. The next one we brought down a 1. Okay, so to solve for a3, we simply take this, which is 1, and we divide by that product, 3 times 2 times 1. And that's going to be what a3 is. Notice that we have a nice form for how we get our coefficients. We have, to get the term for x to the n, we have, so a sub n is the coefficient, and to compute it, we simply take the nth derivative, just use this notation for nth derivative, plug in 0, and divide by n factorial. And that is how we can get our coefficient. Now, that's great. We can get our coefficients that way, but not all power series are powers of x. What if they were like powers of x minus 2? What would we do? Well, we do the same thing, and the same idea would work with the chain rule with the powers coming down, but to get 0 on both sides, we would have to, or to get 0 for most of the terms on the right side where we have lots of powers going up, we'd have to plug in a 2. So we have lots of powers of 0. So really the formula looks very similar. We'd have a sub n is equal to the nth derivative, but now with 2 plugged in, and then again divided by n factorial. So that if we want to find a power series for f of x that's centered at 2, hence this x minus 2, then what we would do is we would write the following: n equals 0 to infinity, f of n, 2 over n factorial, x minus 2 to the n. This is the power series representation. All we have to do right here is find out nth derivatives of the function, plug in the center, and then we divide by n factorial and multiply all that by x minus 2 raised to the nth power. This right here is the power series representation for f, and we can get it by looking at the different derivatives of f. Thanks for watching.